So in 4.4, we're going to work on graphing logarithmic functions. And so some of the ideas may seem familiar to you that we've covered with transformations of other functions. We're going to do a lot of that in this section. But first we're going to talk about domains. So you might remember we had something like, y equals log base b of x, and we said x has to be greater than 0. So when we were writing that function, we needed to recognize that the argument here has to be greater than 0. So that's a restriction we have on the domain. So in example 1 here, we have this argument, x plus 3, so we have to say x plus 3 must be greater than 0. That's an inequality. We solve it. So x is greater than negative 3, and that means then the domain is going to be from negative 3, we're not going to include the negative 3, to infinity. Okay? So that's just what we're doing here, is we're finding the domain. It doesn't really have anything to do with the base, it has to do with the argument. So you take the argument, make it greater than 0, and that allows you to find the domain. So here we have another function in example 2. It's a common log, but like I said, the base doesn't really matter. We're going to take the argument, 5 minus 2x, and make that greater than 0. Again, we have an inequality, so we're going to solve that. Negative 2x is greater than negative 5. We're going to divide both sides by negative 2. But because we're dividing by a negative 2, we're going to get x is less than 5 over 2. That means our domain this time is going to be from negative infinity to 5 over 2. Because it's got to be less than 5 over 2, we had to switch the inequality when we divided by a negative number. So just be aware that those things can happen. It's the same rules that we had for solving an inequality. It does change the looks of the domain a little bit, though, from the previous example. So there's the domain, and that's just what we were working on here, is finding the domain. It's based on the argument, and the argument has to be greater than 0. Remember, the argument is what you're taking the logarithm of. Okay?